Welcome back to Advent of Code 2019. We're up to day 17. Okay. So. Day 17. Set and forget. An early warning system detects an incoming solar flare. Oh, this rim weld is leaking. Yep. And automatically activates the ship's electromagnetic shield. Like, are solar flares potentially... can they affect Earth? Can interfere with shortwave radio communications. But it's not as extreme as, like, an EMP bomb on a city or something. Okay. Unfortunately, this has cut off the Wi-Fi. Oh god, the Wi-Fi. For many small robots that are unaware of the impending danger are now trapped on exterior scaffolding on the unsafe side of the shield. They're using Wi-Fi? Is that really the recommended way of robots communicating? To rescue them, you'll have to act quickly. The only tools at your disposal are some wired cameras and a small vacuum robot currently asleep at its charging station. Video quality is poor, but the vacuum robot has a needlessly bright LED that makes it easy to spot no matter where it is. An intercode program, the aft scaffolding control and information interface, provides access to the cameras and the vacuum robot. Currently, because the vacuum robot is asleep, you can only access the cameras. Running the ASCII program on your encode computer will provide the current view of the scaffolds. This is output purely coincidentally as ASCII code. 35 means hash, 46 means dot, 10 means starts a new line. Output below the current one and so on. Okay. In the camera output, hash represents a scaffold, dot represents open space. The vacuum robot is visible as thingy. Circumflex or whatever, and the others, depending on whether it is facing up, down, left, or right. Okay. When drawn like this, the vacuum robot is always on a scaffold. If the vacuum robot ever walks off a scaffold and begins tumbling through space uncontrollably, it will instead be visible as X. In general, the scaffold forms a path, but it sometimes loops back onto itself. For example, suppose you can see the following view from the cameras. Here the vacuum robot is facing up and sitting at one end of the scaffold near the bottom right of the image. The scaffold continues up, loops around itself several times, and ends at the top left of the image. Huh? Okay, fine. The first step is to calibrate the cameras by getting the alignment parameters of some well-defined points. Locate all scaffolding intersections. For each, its alignment parameter is the distance between its left edge and the left edge of the view multiplied by the distance between its top edge and the top edge of the view. Okay. What exactly is an intersection? At least 3 neighboring hashes, I guess. Okay, fine. We need the sum of the alignment parameters. Okay, once we have this, the rest is pretty easy. Okay. So we run the program and we have to interpret the ASCII, whatever. Yep, we can do this. Alright, so when's the last copy some of this code from? So just do like this basically. We'll just use the encode for now. Okay, so we want to create just like a grid. So should we say grid equals that? We'll just start with an inner row. So we want 4 in, so we want to run the program. Okay, okay, while true, out equals encode.get output. So we get the output. It's going to be an ASCII number. So basically, so if it's 10, we start a new line. If out equals 10. It's an int, right? Grid dot append. So we've got a new else. Gonna put grid, the last list here, dot append. It's R off out decimal, right? No. Cr. See if this works. Row in grid print none type. Oh yeah, none. If out is none, break. Alright. I have to activate my code again? Oh. It's it's already activated. It's asking me to activate for some plugin that I'm not using anyway. Okay, so run. Ah, nice. Perfect. So n equals length of grid, m equals length of grid 0. So we've got the parameters, and we're just looking for intersections, right? Should we make a get neighbors? For a row column, so I'm gonna get all the neighbors. So for delta in, so it'll be -1 0 1 0 0 -1 0 1. So we should do the 4 neighbors. drec equals r plus delta 0 c plus delta 1. Oh, that's new R, new C. Alright, so if new, so as long as it's 0 is less than or equal to new R, which is less than n, and 0 is less than or equal to new C is less than m, yield UR use C. So that's a neighbor. So we just, because the edges, we've got to ignore the ones that are off the grid. Okay, so what we're trying to do, we're looking for all the junctions. For each one, we sum the alignment parameters. Okay. So total equals 0 for so R and C is whatever. For I in range N, or J in range M. So basically, if there are 3 or more hashes, so what we're saying if sum of, so we want neighbor grid neighbor. Why does the license thing keep popping up? I did this a few weeks ago. It should last a year. June 8th, 2024. It's not a long time. Alright, anyway. We have until then. And then I have to renew it again and again and again forever. Sum grid neighbor 0. So that'll be really annoying to come up in a competition. I should be careful of that. Neighbor 0, neighbor 1 equals hash, or neighbor in get neighbors ij is greater or equal to 3. I don't think there's ever going to be a 3 anyway, but just that is a junction, right? Total plus equal. So if this is an intersection, what do we do? We say we take basically the row and the column numbers, indices, distance between, basically multiply the two indices together. Okay, it's never going to be on the edge, but anyway. So it's going to be I times J. Print total. List index out of range. grid, neighbor 0, neighbor 1. It doesn't like the number that appeared here. Ooh. You know what? I think there might be an extra... Probably a new line, and then we terminate. If grid -1, if it's empty, delete it, I guess. That wasn't the issue, but I mean, we should do that anyway. Print. Hang on. Print the actual grid. I want to see what the grid looks like. It does have an empty list at the end, but we... Maybe we've added... Okay. While not grid -1, delete grid -1. Just then, for some reason, there's multiple. Okay. There's like 2 empty lists at the end. Whatever. Eight, 6, 1, 2. Music's a bit loud, actually. Oh my god, I had it at full volume. I don't normally have it at full volume. Hope I was still audible. Okay, so... Too high? Ooh, but wait, what about where the robot is sitting? No, that doesn't matter. Ooh, you could have a weird situation where, aha, see, this point here. It's not a weird situation, that's pretty common actually. You got 3 hashes, but it's not a hash itself. I was supposed to have if grid I j equals more correct to say in hash, or just say in hash in that string there. Even though we can see from the input that's not the case, but it's fine. 3608, so we eliminated quite a few. Oh, didn't show the so basically I changed this because I was counting all those spaces like these, which had 3 hash neighbors, but it wasn't a hash itself. That is not an intersection. We were counting it as one. So and I've also added this to include the carries, even though I don't think it would ever be an issue. But you could make it one. Sort of. Not easily, but yeah. 3608 then. Now for the tricky part. Oh my god, this looks tough. Well, it looks long. Don't know if it's tough. Said it's tricky. Notifying all the other robots about the solar flare. The vacuum robot can do this automatically if it gets into range of a robot. However, you can't see the other robots on the camera, so you need to be thorough instead. You need to make the vacuum robot visit every part of the scaffold at least once. The vacuum robot normally wanders randomly, but there isn't time for that today. Instead, you can override its movement logic with new rules. Force the vacuum robot to wake up by changing the value in your ASCII program at address 0 from 1 to 2. When you do this, you'll be automatically prompted for the new movement rules that the vacuum robot should use. The ASCII program will use input instructions to receive them, but they need to be provided as ASCII code, and each line of logic with a single new line, ASCII code 10. So we're providing input. So we've been prompted for the main movement routine. The main routine may only call the movement functions A, B, or C. Supply the movement functions to use as ASCII text, separating them with commas, and ending the list with a new line. For example, to call A twice, then alternate between B and C 3 times. Provide the string AA, B, C, B, C, B, C. Okay. Oh man. Fine. And then you'll be prompted for each movement function. L to turn left, R to turn right, or number to move forward that many units. Movement functions may not call other movement functions. Okay. Finally, you'll be asked whether you want to see continuous video feed. Provide either Y or N and a new line. Enabling the continuous video feed can help you see what's going on, but it also requires a significant amount of processing power and may even cause your encode computer to overheat. Due to the limited amount of memory in the vacuum robot, the ASCII definitions of the main routine and the movement functions may each contain at most 20 characters, not counting the new line. So the only thing I don't understand is what are these movement functions A, B, and C? They haven't told us yet, I guess. In order for the vacuum robot to visit every part of the scaffold at least once, one path it could take is that. We don't need the shortest one, do we? We just need a path for it to follow. So what if we were to just follow the path? Isn't that kind of optimal? So go right 8. Where's A, B? Oh, A, B, and C were a general... Wait, what? No, I don't understand. Oh, ho, ho. Oh my god. So you're coding... You're creating 3 scripts. A, B, and C. And your movement is only allowed to use those 3. So you need to decide on a definition for the script. And you need to, those 3 functions need to make up the whole movement. What the heck? Of course, the scaffolding outside your ship is much more complex. As the vacuum robot finds other robots and notifies them of the impending solar flare, it also can't help but leave them squeaky clean, collecting any space dust it finds. Once it finishes the programmed set of movements, assuming it hasn't drifted off into space, the cleaning robot will return to its docking station and report the amount of space dust it collected, as a large non-ASCII value in a single output instruction. After visiting every part of the scaffold at least once, how much dust does the vacuum robot report it has collected? So we don't have to find the shortest. But we are limited to... so without the memory limit, you could just apply this whole string and just call A. So we need to somehow decide on an A. Or A will be the first, without loss of generality, A would just be the first script we call. So A will absolutely start with the first commands. So A will be write 8, and then we don't know how much of the rest to make to assign to A. It really depends, doesn't it? So basically you're deciding 2 indices. One for the end of A, and another for the end of the next script. Now if the 2 are the same, we could just say A is called twice. And if it's different, So we can try all pairs of indices, and we can say, okay, everything up to the first index we tried is A, and then everything that goes up to the next index, it's either A or B. It kind of depends. If it's the same, if it looks the same, we could decide it's A, or we could decide B is the same as A. We could just assume we would never want to do that though, because that sounds unlikely to come up. So we could just say that's B. So we could say first part is A, the next part is B, unless the next part is the same. I mean, it could be that we want AA. So then we should just keep going forward until we find the next segment, which is no. Hang on. Okay, that will give us A, and it'll give us B. And then once we've got an A and B, we can work out what C should be. And if it doesn't all work, if we can't find a way of breaking this whole string down into A, B, and C, then those pairs of indices don't work and we move on to the next pair. So if this is at all possible, then we should actually be able to find one, right? But we don't have to follow this path. Or do we? Are they saying we should actually follow this path as it is? Like, can I not just go here, go up, left, down, up, back up, and then go right? I mean, that makes it kind of harder, but that's a valid... It's not forbidden, is it? We can't walk on the empty spaces, because it says you'd fall. So it's A, turn right, go forward 8, turn right, go forward 8. Then B, B, B. Turn right, go forward 4, turn right, go forward 4, turn right, go forward 8. Then turn left, go 6, go turn left, go 2. So first, we need to find this. Break this down into this. Also, I think I might need to... I'm not sure if I can continue this stream right now. Might need to continue this tomorrow. I thought I might be able to finish part 2 quicker than this, but it looks like this is quite involved. So how would we get this sort of thing from that? Just... work out where the nearest hash is and then move, so we can delete every hash we visited. And we want to go forward through junctions. So and it may not be that we, well, like, you don't have to turn right here. You could turn left, left, left. That'd be a bit weird, but oh man. This is something to think about. I think it would be good for me to do more. So when I do streams like this, it might sometimes actually be good for me to do part 1, have a think about part 2, then leave actually doing part 2 for the next stream, because then I can sort of just think about it during the day and not spend literally hours banging my head against the wall like I do in some streams. It might actually make the video, I would still stitch the video together, so that it's one continuous video, but it might actually make it better. And anyway, I can't stick around right now, so I've got to stop. But yeah, I'll have a think about this. My worry is, okay, it might be easier than I'm making it out to be. Like, it might be that you just take the basic, go forward, turn right, go left, go right, like exactly the way it looks. Okay, we can do that. And then it would be a case of just what I said before, picking trying all possible indexes which close off the first A, and then from that point, trying all possible indices which close off the next B. Once you know those, you can then work out what C should be, if C is even possible, by every time you see an A or a B, take them out. Well, sort of. We can make it a bit simpler. We don't have to be as smart as that. Instead, we could just try all possible subsequences that A could be, all possible that B could be, all possible C could be, and then see if we can actually construct that. So if I were to do that, you would... So how many choices of A are there? Well, actually there's a linear choice because we're assuming A must be the first one. So then from whatever's left, let's say A is this section here, right? Then from whatever's left, we can try all possible B's and C's. So that's linear times, so be basically n times the length of the path is n, let's say. So it'll be n for the first index, then linear times linear to get the b, and then maybe another quadratic to find the c. I don't know. In worst case, it's probably like quartic. And how long is the path? Looking at our total. It's not that long. So I think that's doable. Ranging over all A, B's, and C's, and for a given A, B, and C, like then there's an algorithm for this, isn't there? Like a sequencing algorithm, which is used in like biology and stuff. It's like it's like a prefixing kind of. I'll think about it. I think there's probably, given an assignment to A, B, and C, to then work out what the ABC sequence is. Because there's choices you could make. It's not fixed. Like, there could... If one is a prefix of another, if A happens to be a prefix of another, we could assume it isn't. But if it was, then it wouldn't be a unique way to construct it. But I'm guessing I'm just thinking too general here. It looks like the kind of problem where he's just giving us a pretty generous setup. So like you won't have situations where B is a prefix of A or whatever. And we got to remember also that there is a limit. That memory limit helps us. It doesn't harm us. It helps us. At most 20 characters. So there can be at most... That's including the commas? So it's something like... So something we can have something like 10. Oh, that makes it much easier then. So A can only be like 10 things long. So you could actually just try all possible. So you could eliminate a lot of overly long things. Okay. Welcome back to Advent of Code 2019. Day 17, part 2. So we run this int code thing. So last time... Is the music actually playing? Oh, it is. It's quite quiet. Alright. So, yeah. So last time we were dealing with this part 2. Or at least we had a look at part 2. So we end up with a snake-like thing like this. What we've got to do is we've got to find 3 sequences of commands. A, B, and C, such that we could describe this whole path using just A's and B's and C's. Okay, the way I phrase that might not make sense, but like A could be turn right, go forward 8, go left, go forward 7, something like that. B could be turn right, go forward 10, something, 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 and C could be something, something else. And then the whole sequence would just be something like A, C, B, C, A, C, B. The general case probably doesn't have a solution, so this has been specially crafted such that that's possible. And A and B and C can each be at most something like 11, because the restriction is like 20 characters and you've got commas in there. And similarly, individually A, B, and C can only be like 11 commands, I think, so... One path it could take is this. So this example is very nice because A starts with a right or left command, so does B and so does C. And they each end with a forward command, so does B, so does C. It would be, hopefully, we would have the same thing. But in theory, it could be solved where A, for example, ends with a left command and then B starts with a number, I don't know. So we would hope that it just follows the same pattern. It'll be easier then. So if we get this correct, then the program will give us an answer. So it comes down to... So I think step 1 would be to just find this, okay? And they say one path, but there's kind of one obvious path, and that's to just keep going forward all the way. Because if you don't, then it's kind of weird. But theoretically, you could have a path which goes here and then turns left, that goes here and does that and then comes back. But I don't think that would be the case. That'd be... yeah, so let's assume it's not. So we just follow the path. Go forward as far as we can, turn left or right, go forward as fast as we can, and so on. So... Alright, so let's look at the code then. Run it. So we get an image of what this looks like. I mean, you can already kind of see what A is going to be. It's going to be like, go right, go forward that many, go right, go forward that many. Oh, but you know what? Some of these are longer. So that implies that we might actually so if A was the go right, go do this, go down, and so on, then but wait. So that's equivalent here. So here, if we were standing here and we were looking up, so I reckon A would finish somewhere between this. Because otherwise we wouldn't be able to do... If we reuse A for this, we wouldn't be able to do this. So I reckon we stop around here. I mean, we can look elsewhere. Where else do we see, like... So I reckon it's like A is turn right, go forward this amount, turn right, go down this amount, turn right, go forward this amount, and that might just be it. Maybe even turn left. So where do we see A happening? Here. Man, this might be A again. Going this way. We could work this out visually. It might actually be fun to do it that way. Should we try? So, what do we think A is? You don't always have to solve everything with code. Alright, so A, I reckon, is go right. Then we go forward 1, 2, 3, 4, 5, 6, 7, 8. So it's R, 8, R, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Then I reckon you probably do R again. And then go forward 1, 2, 3, 4. And then maybe turn left, I'm not sure. So if I did that. 1, 2, 3, 4, then I'd be sitting here. So B could be something like so let's imagine we turned left at the end of that. Okay. So we'd be sitting here, and we'd be looking to the down. Now B might be something like turn right to cancel out that left. Go forward 1, 2, 3, 4, 5, 6. Turn right. Go forward 1, 2, 3, 4. And then we're ready to do A again. So if we did A again, it would be turn right. So go 1, 2, 3, 4, 5, 6, 7, 8 as before. Turn right. We go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We turn right. Then we go 1, 2, 3, 4. And then we turn left. So we should be here and looking to the left. And now if we did B, we turn again, we turn right. So we do an A, B, A, B. We turn right, go 1, 2, 3, 4, 5, 6. Ah, but this could be A. Turn right. Go 8, turn right, go 1, 2, 3, 4, 5, 6, 7, 8. Oh, damn. It doesn't quite line up with what I thought. But if we were here, we would turn right, go 8, go right, go 1, 2, 3, 4, 5, 10. Somewhere in there we've got the answer. I just can't quite Let's look at the end. The end is here. So somebody has to end with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Someone ends with R12. But how many times do we see anyone do 12? What's this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. I don't really know how to solve this programmatically, but I feel like we could solve it like some sort of Sudoku kind of thing. Shall I just fully write out the sequence? Some coordinates would help. Or should we just count? See if we can solve it by hand. Alright, so let's write out the full sequence. It's going to be right 8, right 10. Is that definitely 10? So this is line... How do I... That doesn't really show the line numbers. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. And then it's 1, 2, 3, 1, 2, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's on 10. Interesting. And then R. 4. R. 1, 2, 3, 4, 5, 6, 7, 8. It's 8. R. Did we ever do a left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's R. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. R. 1, 2, 3, 4, 5, 6, 7, 8. See, there's so much repetition. We just need to find out what. And then more R's. Are we ever turning left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. R. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. R. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then R. 1, 2, 3, 4. Now we finally get left. Left. And then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then left. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. Interesting. Then R. 1, 2, 3, 4, 5, 6, 7, 8. I can guess these numbers roughly. So then it's R. And that's 10, isn't it? Then R. Then 10 to get there. Then R. Then 1, 2, 3, 4. Then R. Might as well just do the whole lot. Now it's 1, 2, 3, 4, 5, 6, 7, 8. R. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. R. So, hang on, so 8, take us here, 9, 10, 11, 12. R. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. R. 1, 2, 3, 4. Just gonna end up solving this by hand. We've got left. Let me guess, it's 12. Alright, I can sort of see what it's gonna be. 1, 2, 5, 6, 7, 8, 9, 10, 11, 12. Left. So is it 12 again? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. So I reckon L12 is just something on its own. Then it's R. 1, 2, 3, 4, 5, 6, 7, 8. R. But where did... Oh, so there's an R... There's R4s in there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. R. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. R. 1, 2, 3, 4. So there's R4s. I'm not sure what to do about them. Then R. 1, 2, 3, 4, 5, 6, 7, 8. I know this must be so boring to watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8, 9, 10, 11, 12. All right, this is make every time every step we're doing makes it easier and easier to figure out what the script is. R. 1, 2, 3, 4. Left. Ooh. Ooh, now this is weird. Oh no, that's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, that's fine. And then finally left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, I reckon we call it's not entirely clear though. Clearly we've got an L12, which is a sequence. So I think L12 is just one sequence. Call that C. A definitely starts off as R8. Then what? Nope. So it goes R10, R8, R10, R10, R4, R8, R10, R12, R8, R10, R10, R12. What? it's not obvious then. Like, where does R12 come from? Every now and then R12 pops up, and that's confusing me. So I reckon A might be R8, R10, R10, R4, R8, R10. Because that's always the same every time we start with R8 again. Not always, but sometimes. R8, 10, 10, 4, 8, 10. 8, 10, 10, 4, 8, 10. And that would mean 8, 10, 10, 4, 8, 10. The other sequence is 12, 8, 10, 10, 12, 4. Twelve, 8. What? No, it's not. The heck? 8, 10, 10, 4, 8, 10, 12. I reckon it's a bit sneaky. I reckon you have to throw in a left somewhere in the A's and B's and C's. Also, okay, so L12, L12 always comes together. So it's R12, 12, 12, 4, 12. 12, 12, 4, 12, 12. Hang on. Right, 12, 12 is always... L12, L12 is always preceded by something like R4, R12. Oh, God. Wait. This is not helpful, is it? Because I'm not writing anything down, so it's like the most boring thing ever to watch. Let me write down what I've found. So this is the sequence. R8, R10, R10, R4, R8, R10, R12. Now we could just run an algorithm to find out what the... R8, R10, R10. I feel like we should group these together. It seems like they always come in pairs. Although there might be a catch to this. We might need to separate them, but for now we can group them. So what was that? That was L12, L12, R8, R10, R10, R4, R8, R10, R12, R12, R4, L12, L12, R8, R10, R10, R4, R8, R10, R12, R12, R4, L12, L12. Okay, it's kind of, you can see that there's a... Alright, when there's L12, it always has R4 and R12 beforehand. So we could say maybe, let's say C equals this. In which case this would become like that. Now, without loss of generality, A should really start with R8, so it might finish like here. Oh, I think I see it now. Yeah, I should have typed this up. It's clearer. A equals that. And B equals this. That's tricky, because B is a prefix of A. So some methods you use might catch you out if you're assuming they don't share the same prefix. One isn't the prefix of the other. Wait, so that... Let's make sure this is completely correct. 4, 8, 10, or 12, that's A. And that is B. And then... That is A. And that is A. We've solved it purely by hand. Okay, let's do this then. So what do? We have to... how would I actually go about solving it programmatically? I'm too lazy to do that. If you can do it by hand in a reasonable time frame, why not? So, we need to give... How are we formatting this? We need to give input. So the first input is the main movement routine. And then a new line. Okay, so move routine equals, it's gonna be this basically. It's gonna be A. But so you have to give the ASCII code for each one. So we're doing part 2, so we do this, refresh it. We want to change the first, this to be a 2. So we run a new ink code. So for car in move routine, int code dot put input. What was fixed input again? Provide fixed input. We just want to provide input, don't we? Put input, yeah. So it's gonna be the odd value of car. And then we put a space. And then we do A equals this. So this is going to be a string as well. Wait. Isn't this too big? Hang on, let's look. What is the size? Each may each contain at most 20 characters, not counting the new line. So how long is this one? So this is R8, R. Isn't that a bit big? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It's too big. Oh, I'm so dumb. If B was a prefix of A, then that means you wouldn't need A to be this. A would just be this. Or the other way around. Swap A's and B's. Let's make A... Why did I delete the whole thing? The long one. Alright, let's just hope this is correct. Hang on, stop losing stuff. Alright. So I'm saying... Yeah, A is that. B is that. So whenever we see A, we actually mean A, B. Is that right? So it goes 8, 10, 10. And then B, 8, 10, 12, 12. 8, 10, 10, 12. Four, 8, 10, 12. Something isn't right here. Why did I delete that whole big sequence? Hang on, can we... I think I meant... So it's A, B, 4, 8, 10, 12, A, C, A, B, C, A, 4, 8, 10, 12, B, C. Okay, that's fine. It's this. A, B, A, C, A, B, C, A, B, C. B, A, C, A, B, A, C, A, B, C, A, B, C. A, B, A, C, A, B, C, A, B, C. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 19. Okay, that's fine. Okay, so A is this. Damn it. B equals that. Okay, I made a mess of this. Alright, 8, 10, 10. B equals that, that. And then C equals... Everyone's got different inputs, I guess, so some might be harder than others to do by hand, like what I'm doing. Okay. And then just do this each time. Then it should just do it. And then what? No more inputs? You'll be asked whether you want to see a continuous video feed. Provide either Y or N and a new line. Let's say N. We trust our calculations here. So we just get one output, and that's going to be the number. Let's say dust equals... 46? It's a small number. It gave us a number. It will probably give us an error code. If otherwise. A large non-ASCII value in a single output instruction. Large? That's not large. I'm a bit worried now. 46. Should we try it? It's definitely not large. No. Pretty sure I've got the routine correct. We just need to... Are there outputs we're missing? Like, are we supposed to be collecting some outputs along the way? Did I change program to a 2? Yes, I did. Okay. Does it give us any more outputs? Let's try fetching a second output. Maybe it's fetching 46 again? What's... Oh! I think we're supposed to do all the part 1 stuff still, fetch the grid. It's a bit confusing, because I thought the implication of changing 1 to a 2 would be that we just read what's described in part 2, but I didn't know it would still do all this stuff, so we need to do this. Basically. Just clear all the outputs to begin with. 46 is a dot. So clear all the outputs. No, not there. Oh, here. Okay, do that. Now what? If out is none. Oh. The problem is that we're now hanging, waiting for, because of the way I've designed this. Why couldn't they have... Okay, fine. Do we just, so should we just do this? Or in range, it's gonna be M plus 1 to count for the new line character times N, that's how many characters we're gonna get. Let's do that. 10? No, that can't be right. Oh! Is it plus 1? Because you get 1, or 10 is another new line. 77? That still seems small. I thought it'd be... Well, they said large. Also, I forgot to show my... No, I didn't. Alright, let's try it. I mean, now we've actually got a number, I think. 77. What is 77? It's an M. I don't think. A large non-ASCII value in a single output instruction. Are there any more outputs at the end? There are. What's with all these outputs? Is it spelling something out to us? Dots, dash, dots and hashes. Why? It's describing a map again. Oh my god. Oh my god. It's talking to us. Main, function A, function B, function C, continuous video feed. What is it doing? I don't want continuous video feed. Is it doing continuous video feed? How do I turn that off? I just want the final answer. What? This makes no sense. I don't think they're properly describing the order of inputs and outputs here. They didn't say anything about having to fetch output for this grid over and over again. Hang on. Provide either Y or N on the new line. Oh, I'm not showing the by charm. This is what we're getting. We're getting a message from them. So it's asking us, do you want continuous video feed? Stuff like that, questions. But we've provided the inputs already, so it's like... it's on the queue. So we don't actually need to read the prompts. Main function A, main function B, function C. Continuous video feed. Maybe you take one out. I'm lost. Do we actually need this? I don't know. Let's take it out. Alright, so we start off with this grid. Okay, so we were right to do this, I think. That just clears some of the stuff. They did not tell us we would have to fetch this output after providing the... inputs. The whole point of not asking for the continuous video feed. Provide either Y or N and a new line. Alright, is the format correct for these? So we put 10 after each one. So we do that, then we put 10. Then we put... that, then we put 10. That, we put 10. That, we put 10. Then we just put the N character. And we put 10. So why is it giving us the... I don't think the description for this is correct. Like, if we say N, then we shouldn't be getting this feed. They said, after visiting every part of the scaffold at least once... Wait, it says... When it finishes the programmed set of movements, assuming it hasn't drifted off into space, the cleaning robot will return to its docking station and report the amount of space dust it collected as a large, non-ASCII value in a single output instruction. Single output instruction. They didn't say anything about printing grids again. What happens if I put yes instead of no? We don't get an integer at the end, so okay, it's I guess it's just showing how do we get output without hanging? Turn next self to automaton. I don't know. I don't know how to set this up such that we can see these prompts and answer to them. You wouldn't think you would need to. You can just provide the inputs whenever you have them. So, okay, the Y-N thing does seem to do something. It's just that Y provides lots of images and N just provides one. Which is dumb. We don't want to see any. I didn't ask for any images. But... just move these up here. Let's just say out equals list if dust is none, break out dot append. Oh my god, I think I know what the issue might be. That last number is just a raw number, so we don't do CHR for that one. Everything else is ASCII. So if I just do this... There we go. It was into, that's why we had a weird character at the end. It was interpreting the answer as ASCII, but it wasn't supposed to be ASCII. Yes! So we basically solved that by hand, except we didn't, because we need the ink code. But the ink code is a black box at this point. Okay, that was actually an interesting problem. And I kind of solved it by hand when there's probably an algorithm that can do it. Now that I look at it, the algorithm wouldn't be that hard to do what I did by hand. It would basically first find that long sequence, R8, R10, R10, so on. Once you've got that, you know A, we can just say A starts at the start. So A, you can choose, you could decide how many characters long A is going to be. You could try 1, then 2, then 3, then so on. And for each of those, you can say, okay, this is A. So B will be whatever comes next, or maybe A again. And then you can sort of infer what C would be. It's a bit hacky. I'm not sure what a nice clean approach to doing it though is. I mean, how long is this sequence? You could just take all substrings. And for each substring you say, okay, A is this one, B is this one, C is this one, and see if that works. But then you'd actually have to run. I don't know. I did it by hand. It worked. Okay, pretty cool. Many worlds interpretation. We could just take a sneak peek. I'm not going to do this now. Looks like some sort of map where you're moving about shorter steps, but there's lots of letters. That's weird. Is some sort of traveling salesman problem? Okay, find out next time. 18. Ooh, 18 looks like it might be a tough one. Yay. And then it gets kind of, yeah, it's hard to interpret anything from this, to be honest, because inevitably people stop eventually. Many people don't make it to the end. They may give up, they may find it boring or too hard. So it's always going to decrease, even if there were some easier problems later on. Like 19 seems to be implied that it's easier, but you can never really tell from this. Let's have a look at the leaderboard. My leaderboard. This is 2019. Oh, I've almost caught up to Patagonia. Who's this? Is this a new entry to my leaderboard? Okay. Captain Coda? Okay. Fun. We are 2/3 of the way through. I'll try and pace myself. No more than one problem a day, if even one a day. This is quite nice, this diagram here. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. It's 18 about Pluto. Oh no, that's Neptune. Wait. Is that the Sun? Mercury, Venus? What's the... Oh, is that just the Sun in the middle? Or... I don't know. Maybe we went to the moon at some point? So that's Venus. Mercury, Venus. This one's Earth. Don't know what this one is. Mercury, Venus. That one should be Earth. Oh, that's Mars. Mercury, Venus, Earth, Mars. Jupiter. Should be Jupiter. Saturn. Oh, that's Jupiter. That one's Jupiter. Saturn. Uranus, Neptune. Okay, so that's Jupiter. And what's this? Ceres Monitoring Station. What? It's not a planet, it's just some sort of station. So that is just a station. Before it is Mars. Okay, so it goes Mercury, Venus, Earth, Mars, station, Jupiter, Saturn, Uranus, Neptune, and then I guess Pluto's out there. Why is the station orbiting the sun? I don't know. I don't know what. I guess the asteroid belt would be orbiting the sun. Yeah. You'd have thought they'd just put the station orbiting a planet or something. Okay, enough. See you next time. Bye bye.